Hello everyone. So we will be starting off with strings today, and we are solving LeetCode 242 called Valid Anagrams. So the problem says that we are given two strings S and T, and we need to return true if T is an anagram of S and false otherwise. So as you can see, I have also shown sample examples. So in the first example, uh, first let's talk what is an anagram. So anagram is basically uh, a word formed by rearranging the letters of any word. Like the word was, suppose the word is ABC. Now, in whatever possible ways we can arrange that, let's do that. It can be BCA or ACB or whatever. So these all are anagrams or CBA in fact. So the from one word we just rearrange the letters of it and we get anagrams. So this is our question. So let's look at the first example. We have this S string is anagram and the T string is this. So here you can see we can obtain this T string from rearranging the letters of the S string. Similarly, let's look at the second example. So here the S string is rat, but the T string is car. So whatever we try in any way, we cannot reach T here. Since here we have CR, here we also have R, so no problem. Here A, here also A, so no problem. But here we have a T, and here nowhere we have a T. So T is missing from here. Similarly, here we have C, but in S string we don't have a C. So that's why they are not anagrams. So we return false. So I hope the question is clear. So I would be discussing two approaches to solve this. So let's head over to the first approach. So this is the first approach. In this, we will make two arrays to track the frequencies of every letter present in S and T strings. So one array will be for string S, another will be for string T. So we can name it, say, frequency of S, and this one frequency of T. It would be say 26 sized, since in the question it's given that we will only have lowercase letters, and we know lowercase letters are 26 in number. So we would make a 26 sized array. Since it's 26, the indexes will be from 0 to 25 each. And initially, everything will be filled with zeros. So 0 will be filled everywhere. These both will be integer arrays. So now we just will keep track of frequencies and suppose we first go to the S string and we come to A. So increase the frequency of A and it becomes 1. Then we go to N. So we get the position of N. To find the index, what we will do is we will do the current character minus A. This will give our index value. For example, suppose character is A. So we do A minus A, which is 0. So if A is encountered, 0th index value would be incremented by 1. Similarly, suppose character encountered is C. So index is character minus A. This will give 2. So index would be 2. I hope it's clear. So like this, we would traverse the entire string and update the frequencies of every letter. Similarly, in this array also, we would do the same and update frequencies in the frequency T array. Now, After we have filled both the arrays, we would observe that both the arrays would exactly be equal because suppose we had a S equal to say A, B, C, and A, and T was you can say C, B, double A. So here you can see in a string A occurred two times, B occur once, and C also occur once. And here also you can see frequency of A is 2, B is 1, and C is also 1. So it doesn't matter how you arrange them. At the end, frequencies of all letters in both these strings would exactly be same. Here A also occur twice, here also occur twice. B occur once, B here also occur once. C once, and here also C occur one time. So this was the entire crux of the problem, and this is how you will solve it. Coming to the time and space complexity. So since we are traversing both the strings, so the time complexity would be m plus n, where m is the length of the first string, which is s, and n would be length of second string, which is t. And also we can do an early check. Suppose if we have s and t, right, strings. If they differ in length, then they can never be anagrams. I hope it's clear why I'm saying that. So suppose S is something like A, B, C, and T is suppose E. Then they can never be anagrams, right? Because after rearranging the letters, the number of characters can't change, right? So yeah, so we can make this write this early checks that if length of S is not equal to length of T, then directly return false. So this is the early check we can write. So this was the first approach. And coming to this space complexity of it, since we are making two arrays of size 26, it's 2 times 26, which asymptotically is equal to constant space. So the time complexity is sum of both the strings length and the space complexity is big of 1. So this was our first approach. I hope it's clear. So let's head over to the second approach. Now let's see the second approach. So I've taken another example here. S is this and T is this. So here frequency of A is 2, B is 1, C is 1, and D is also 1. And here the frequency of A is 1, 2, and B is 1, C is 1, and D is also 1. So frequencies match of every letter, so they are anagrams. So we would return true in this case. So one thing we can observe, uh, what if we sort both these strings? Let's see what happens. So let me write it here. So S was C, B, A, D, A, right? And T was A, B, D, C, A. If we sort the strings, let's first sort the S string, it becomes A, A, B, C, D. And similarly, sorting the T string, the string becomes A, B, C, D. So I hope you know now what we will be doing. So if the two strings are anagrams, sorting them would always give same values. Like here also, we after sorting we got double A, B, C, D, and here also after sorting the T string we got double A, B, C, D. So we can just sort the two strings, both the strings, and check for their equality. If they are equal, we return true. Otherwise, we return false. So this was our second approach, coming to the time and space complexity. Since we are sorting, time complexity is n log n. And since we are using no extra space, space complexity is big of 1. So yeah, this was our second approach, and I hope you like both the approaches. And uh, let me also show you the code of both of them so you can get a clear understanding of both the approaches. So I have written the codes of both the approaches. So in first approach, as you can see, we created two arrays, frequency of S and frequency of T of size 26 each. Then we just tracked the frequencies and updated them. First for string S, and then we did the exact same thing for string T. And at the end, we just checked whether contents of both the arrays are equal or not. This arrays.equals function is used to check whether two arrays are equal or not content-wise. And in the second approach, the code you can see, we first we converted both the strings into their corresponding arrays. Like string suppose was ABC. So we first converted it into an array like this character array. So that we did so that we can use the sorting function arrays.sort function, which is a function which is applicable on arrays only. That's why we converted first our strings into arrays so that we can utilize this function. So we sorted both the arrays and just check whether both are equivalent or not. If they are equal, we return true, otherwise false. So this was the code of both the approaches. I hope you liked the video and yeah, thanks. Thank you so much for watching.